Nucleophilic substitution reaction. Actually, we have two types of reaction. Sn1 nucleophilic substitution reaction first order, Sn2 nucleophilic substitution reaction second order. And we have internal nucleophilic substitution also, but that is beyond your scope. So let me consider first Sn2 and Sn1. Now let us consider nucleophilic substitution 2. Let me consider CH3 X. This is the haloalkane where the hydroxyl ion, that is the nucleophile. And this X is the leaving group. Lg means leaving group. Because of this, you are able to get the carbonium ion. So this is called carbonium ion, C+. And this nucleophile goes in search of carbonium ion. That is why it's called nucleophilic substitution reaction. That results, so CH3 and X has left out, so OH is added here, substituted here, and the leaving group is X minus. Halogen is left, and this is alcohol. So this is alkyl halide. And here you can have alcohol. The speciality about the nucleophilic reaction, substitution reaction 2, second order. Actually, it is a bimolecular reaction. Second order. Second order reaction. It means the rate of the reaction depends on the alkyl halide and also on the hydroxyl ion present here. So that is why it is called second order. It depends on two reactants, 2 moles of reactant, 2 moles of two different reactors, and you have a single step reaction in this case. So these are all the salient features of Sn2. Let us consider carbon here, hydrogen, 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 and this is also hydrogen. So instead of a hydrogen you have X here, and this is the leaving group Lg. So it forms an intermediate like this, and there will be an OH minus ion, and this is the nucleophile. It attacks from the back side, so it's called backside attack. And this is the leaving group as chloride anion. So both attack and leaving take place simultaneously and forms an intermediate, and this carbon they get adjusted like this. So H, H, H. This is a trigonal planar arrangement. On both sides you have the attacking species. What is the attacking species here? OH. What is the leaving group? Cl. So it is about to leave, it is about to attack. So it forms a trigonal bipyramidal structure. A transition complex is formed. A transition complex. And its structure is trigonal bipyramidal. Trigonal bipyramidal structure. Trigonal bipyramidal structure. So trigonal bipyramidal structure. Okay. Then it is fully removed and this is completely attached, so that you are able to get C, and this bond will come here, H, 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 and here OH is attached. So this is the alcohol. So actually this is primary alcohol. This is primary alkyl halide. So this is regarding Sn2. The speciality of this structure is actually this occupies a single plane, trigonal plane, and one is above the plane, one is below the plane. So Cl and Cl, trigonal bipyramidal structure. This H is above the plane of the paper, and this has partial negative charge, and it attains the cation, carbocation. So this is regarding Sn2. Now let us talk about Sn1 mechanism. So let us consider tertiary alkyl halide C, CH3, 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 X, that reacts with hydroxyl ion OH minus. So it forms CH3, C, CH3, CH3, and instead of X it is replaced by OH minus, that is OH, and the chlorine is left out. So this is tertiary alkyl halide, whereas this is tertiary alcohol. Now let me explain about the mechanism here. You have got this C and CH3 like this, and here X. So actually it has a two steps. It's a two-step mechanism. The first step is, that is, generation of the electrophile. Okay. So this is the two-step process. We have here tertiary alkyl halide. First here the generation of nucleophile, carbonium ion. So first ionization takes place, so it becomes C, CH3, 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 and forms plus. Carbocation is formed, and the leaving group has left. So here the formation of carbocation. This is the carbonium ion, is it not? Carbonium ion. So once the carbonium ion is formed, then this carbonium ion is attacked by the nucleophile. So since it has this structure, okay, it has the chances of attacking from both sides. So it's called both side attack. OH minus ion can attack either from here or here because it is symmetric. So this is called both side attack. So it forms, that is CH3, 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 and this OH minus ion will fuse together to form tertiary alcohol. And what is the specialty about this? In fact, this OH minus attack, okay, so this is the attack, and it can take place either on this side or this side. So there is no change of symmetry in this case, whereas in the case of Sn1 there is a change of symmetry. Okay, so here it is on the right side, the leaving group, X is on the right side, but when you find here it is on the left side. So change of geometry, not symmetry, geometry. Here there is no change of geometry. So what's the difference between this bimolecular second order, and in fact here it depends on the that is single reactant only, okay, the attacking species only. So therefore we can say this is a first order reaction and this is second order reaction. Are you able to follow? Okay. And there is no change of symmetry. And here polar solvents influences in the case of Sn1 because the formation of cation is very important. So polar solvents influences, and here polar solvents does not influence. And you may be asked such type of question, what are the differences between Sn1 and Sn2? So what you can do, Sn1, Sn2 both are bimolecular, but Sn2 is second order, Sn1 is first order. Why? Because here the R is proportional to Rx and the rate of the reaction is proportional to, it depends on two substrates, one is Rx and the OH minus, whereas in the second case it depends on only Rx, the substrate only. Okay, that is with the Sn1, and it's a single step with the formation of transition complex, whereas Sn1 is two-step reaction. First is formation of carbocation, second is attack by nucleophile. Okay, and there is a change of symmetry, geometry in the case of Sn2, whereas in the case of Sn1 there is no change of symmetry. Why? Because there is a backside attack. So this change of symmetry is due to what? Backside attack. But in the case of Sn1, there is no such backside attack. Instead, it can attack from both sides. Why? Because the carbonium cation is getting ready. It is ready for the attack. Okay. So these two are very, very important. And here polar solvent does not influence because it does not depend on the ionization, whereas in this case ionization should take place, and only after that this attack occurs. Okay, and there is no transition state here, transition complex intermediate, but here there is an intermediate, right? Are you able to understand this? And what is the example for this? That is here hydroxylation, that is hydrolysis of alkyl halide. Okay, so conversion of primary alkyl halide into alcohol by the nucleophilic attack. Okay, whereas that is Sn1 is tertiary alkyl halide. Okay, so here the order of preference is, priority is, that is primary is more dominant than secondary, that is more dominant than tertiary, whereas that is the reverse of. Are you able to follow? So here it is because of the steric effect, they get ionized and they split into carbonium ion and leaving group anion. Okay.